You know that feeling when you use Canva? It's kind of like magic, right? You just drag an image, you type some text, and everything just works. But behind that super simple interface is one of the most complex and honestly fascinating engineering systems out there. Today, we're going to pull back that curtain and see exactly how they built it. First things first, let's just try to wrap our heads around the scale here. We're not talking about some small niche app. Canva is serving over 150 million people every single month. That's millions of people all editing at the same time, uploading petabytes of data, and all of them expecting it to be flawless and instant. The engineering challenge is just wow. So that really brings us to the big question for this whole explainer, doesn't it? How on earth do you architect a system that can handle that mind-boggling scale, but at the same time, make you feel like you're the only person using it? It's this incredible balancing act between raw power and elegant simplicity. All right, so where do you even start building something that massive? Well, you start with a master blueprint. This is the high-level architecture, the big picture strategy that Canva uses to make sure every single one of those millions of clicks and drags goes to exactly the right place. And it all begins right where you'd think it would, with you. Layer 1 is you. Whether you're on your laptop in a web browser or on your phone in the app, your clicks, your drags, your keystrokes, that is the very first layer. That's the spark that kicks off every single interaction in the whole system. Now, your actions don't just wander around aimlessly. Nope, they are all routed through one single, super smart front door. It's called an API gateway. The best way to think of it is like a maitre d' at a huge, fancy restaurant. It greets every single request, checks your reservation, and knows exactly where to send you next. And where does that gateway send all those requests? To a whole team of specialists. See, Canva uses what's called a microservices architecture. This just means different services handle different jobs. There's one for your user profile, a different one for your design data, and another one for managing all the photos and videos. It keeps everything neat, tidy, and easy to scale up. And finally, holding this whole thing up is the foundation, the bedrock. This is the data layer. It's a powerful mix of databases, crazy fast caching systems, and enormous storage solutions. This is the part of the system that actually remembers all your designs, stores every single image you upload, and just makes the whole thing run smoothly. Okay, so now that we have the blueprint, let's dive into the first major challenge, real-time collaboration. I mean, how does Canva let you and your entire team jump into the same design at the same time without it all just descending into absolute chaos? This is a massive engineering puzzle. So what are we really talking about here? Well, real-time collaboration is that pure magic that happens when you move an element on your screen and it instantly moves on your colleague's screen, even if they're on the other side of the world. It's all about making a shared digital space feel truly alive and connected. Now, this is where it gets really, really tricky. Just imagine you move an image to the left at the exact same millisecond your colleague deletes it. Uh-oh, what's the right outcome? To solve this, engineers use some really sophisticated strategies. One is called operational transformation, or OT. Think of it like a central referee that looks at every action and adjusts it based on what everyone else is doing. Another approach is called CRDTs, and these are wild. They're designed so that even if edits arrive in a weird order, the math just works out and the final result is guaranteed to be the same for everybody. It's a critical choice for keeping everyone's work in perfect sync. So let's break down the flow. It's kind of like a little four-step dance that happens in a flash. Step 1, your app sends an action, like move this image over here. Step 2, the service receives it and puts it in the correct order. Step 3, it blasts that change out to every other person in the design. And finally, step 4, it saves the change permanently. This little dance is happening hundreds, even thousands of times a minute. So that's how people can all work together. But what are they working with? Well, that brings us to our next giant puzzle. Managing a library of assets that's, for all practical purposes, infinite. Every single stock photo, video, icon, and font has to be stored, categorized, and then delivered to you in milliseconds. And again, the scale is just staggering. We are talking about petabytes of data. A single petabyte is 1,000,000 gigabytes. It's like having this enormous digital warehouse full of creative assets, and it all needs to be perfectly organized and instantly searchable. And this is a great look at how they manage it all. You can't just dump everything into one giant box. You have to use the right tool for the job. So the actual image and video files, they go into something called object storage, which is built for massive unstructured files. But the information about those files, the tags, the titles, the searchable stuff, that goes into a very structured database. And the really popular hot assets, they get special treatment, copied onto a content delivery network, or CDN, which puts them on servers all over the globe so they get to you at lightning speed. This whole right tool for the right job philosophy goes for their databases too. For the really structured, gotta be right data, like user accounts and billing, they use a classic, reliable relational database. But for the more flexible, always changing stuff, like the design drafts themselves, a NoSQL database is a much, much better fit. Okay, we've designed, we've collaborated, we've pulled in assets from that huge library. Now for the final step, exporting your creation. Clicking that little download button actually kicks off a surprisingly complex process to turn your digital design into a real, tangible file. So here's a key insight you might not know. When you click download, the really heavy lifting isn't done on your computer. Instead, you're basically sending a work order to Canva's powerful servers. This starts what's called an asynchronous job, which is just a fancy way of saying a process that runs in the background to build your design perfectly without slowing your own computer down to a crawl. And this whole process follows a really clean pipeline. Your request goes into a line or a queue. A special rendering service grabs it, loads up all your design data and assets, and then generates the final file, a PNG, a PDF, a video, you name it. Once it's done, you get a little notification that your download is ready. It's a clever way to keep your browser from freezing up on those big exports. But this process has its own headaches, for sure. Two of the biggest challenges the engineers have to deal with are, one, font consistency, making sure the letter A you see on your screen is the exact same A that gets rendered on the server. That's way harder than it sounds. And two, performance. They have to manage these massive, unpredictable spikes in server usage when, say, millions of people all decide to export their high-res videos at the same time. So let's just zoom out for a second and look at the big picture here. We've seen how Canva handles collaboration, assets, and rendering. All these complex pieces have to fit together perfectly to create that simple, magical experience. But where is all this technology heading? So if you boil it all down, it comes to this. The engineers who built this system say their world revolves around solving three core problems, day in and day out. Making sure collaboration is always perfect, handling more and more scale, and delivering lightning-fast performance. Correctness, scale, and performance. That's the mantra. And that brings us right to the future. With AI that can generate incredible designs from just a simple text prompt, the whole game is changing again. So I'll leave you with this question to chew on. As AI becomes less of a tool and more of a co-creator, what do you think the next great system design challenge is going to be?